about the phase 1 of the assignment. First, we load all the ECG file to plot the ECG signal, and we set the frequency to 1000 Hz as stated in the question, and the ECG1 versus time graph is plotted. I will only explain about ECG1 because it will be used in phase 2 and phase 3.
This is the coding for phase 1. First, we load the ECG1.mat file and we use this formula to make the x-axis in time domain. When we run, this is the graph that we will get. As we can see from the graph, there is noise in this signal and it is not filtered yet.
My name is Nurlena and I'll explain phase 2 of this experiment. For phase 2, we were tasked to plot the ECG signal in frequency spectrum. Basically, there are the frequency spectrum, we can plot them in single-sided or double-sided. But for our group, we choose single-sided spectrum in order for us to see the output more clearly.
So for MATLAB coding, the given signal is in time domain. So to transform them in frequency domain, we use command ABS and FFT. ABS is the absolute value of element of X, and FFT is the fast Fourier transform which singles out specific frequency and allow us to observe the signals in a frequency domain. So we run the MATLAB, and this is the output of the frequency spectrum. Single-sided frequency spectrum.
I am Nora and I will explain about the phase 3 of this assignment. In phase 3, we need to filter the 50 Hz noise from the ECG1 signal, and our group has decided to design an FIR filter. To design an FIR filter, we need to know 4 window functions, which is Hanning, Hamming, rectangular and Blackman. Our group has decided to choose the FIR filter with Hamming window function.
So this is the coding for phase 3, which is design FIR filter using Hamming window. So the cutoff frequency is set to 200 and the number of order is 50. And this is to design high pass FIR filter. So we run this coding and it acts as high pass filter. But for our assignment, we use low pass filter. So we run this coding. And now the FIR filter is low pass FIR filter. So this is the overall coding for phase 3. And I will explain about the filter. So we have decided to choose the FIR low pass filter using Hamming window function. The cutoff frequency is set to 40 because we want to filter the 50 Hz noise, and the order of filter is set to 200. So the higher the order of filter, it will be better in filtering. And this is the formula for omega C. And the function FIR1 is to create the FIR filter and acts as low pass filter, Hamming and +1, which is the length of the filter. And this command shows that the output for the ECG1 after filtering. So this is the coding for unfiltered ECG1 signal as I mentioned before. For filtered ECG1 signal coding, we change the plot to command to output as we assign here. The rest of the coding remain the same and we can see the output of the filtered ECG1 signal.
For plotting of the unfiltered frequency spectrum, we just use the previous coding from phase 2. Then here we assign the new parameter Z equal to output from the filter. The coding remains the same. The difference is just that we change ECG to Z. Then we run this coding. This is the output of the filtered ECG signal. Therefore, the design of the FIR filter is successful.